All right, we've taken a look at Mars in sort of mythology and legend and how that's evolved over time. What we're going to do next is, in this lesson, take again, a historical look at kind of the scientific trajectory of the study of Mars. And we're going to touch on some things that we'll revisit in some later videos in more depth. All right, so it's kind of like an overview of how the more scientific perspective has changed. In particular, just how our view of Mars has gotten so much better, like unbelievably better in the last 500 years. So we have to start with, then, if we're talking about scientific analysis of Mars, we have to start with the telescope, right? So Galileo first turning the telescope to the planets, and this is what he observed, right? So what we have are some really important discoveries that he made, and these are, of course, just his drawings. One is rings on Saturn. He didn't know they were rings, but he did observe, in fact, rings on Saturn. That's the symbol up here. The letter here, symbol, represents Saturn. Of course, he also observed the phases of Venus, which is a critically important observation, providing evidence that the Earth actually goes around the Sun. I believe we learned about that before. And then we have Mars right here. You see Galileo's very detailed drawing of Mars, which is a circle. Okay, so this is what it looked like to him. He couldn't distinguish any other distinguishing characteristics of Mars with his early observations. Now, if you fast forward like 100, 200 years later, you get Cassini and you get a dude named Herschel who were able to make better drawings and better observations of Mars, and they were able to see kind of like darker areas and lighter areas, and even like a little glimpse of like polar caps, like bright white spots. And so their drawings were able to show that there is this detail on the surface of Mars. In fact, those observations, which is just kind of astounding to me that this is in the 1700s, they could actually determine the rotational period of Mars by making detailed observations of those features and how they rotated on the planet. And so they were quite accurate measurements. Now, as the observations continued, they were even able to see other changes on the surface of Mars. Now, all of this corresponds to improvements in telescope technology, right? And as the telescopes got bigger, as they got better, you could see more detail. So, what does this picture illustrate? It shows that they could see the ice caps, right, changing. It shows they could see that the vegetation patterns, these dark regions, were actually, I call them vegetation. That's what they thought they were, right? That those patterns were changing, those dark areas were changing. So they thought that this was like a seasonal variation, that you had areas of vegetation that would grow and shrink, much like you do on the Earth. Right, on Earth we have, right, like snow just covers half the planet and then it recedes and it turns green. So green to white and green to white. Right, so we thought something similar was happening on Mars. Again, this is now the mid-1700s. Okay, so that's these observations, pretty good. Now, as we pointed out, that this respected scientists were making claims about not just life on Mars in the form of vegetation, but potentially intelligent life, right? And so as these observations were coming in, one really very respected mathematician and scientist, Carl Gauss, and we have a number of equations in physics and in mathematics that are attributed to him, but he put forward this idea, which he took quite seriously, that we on Earth should make a large right rectangular triangle, or a right triangle, and with the thinking that any intelligent, sorry, I can see that I'm making it for me, a right triangle. Can't you see my little? Okay. In fact, here it's called Gauss's Pythagorean right triangle proposal. We make this enormous triangle on Earth, like in the snow, all right, so that the Martians could look with their telescopes at the Earth and see that we've made this triangle, and it's like, see, intelligent people live here because we understand fundamental math. All right, so these observations, again, were informing thoughts and ideas that were what we would consider a little bizarre. Now, the maps of Mars got better and better as the technology continued to improve, the telescope. To illustrate how difficult this is, though, I wanted to show you some maps made by these two scientists, Beer and Madler. And I got to look at the date. Okay, so this is mid-1800s. Okay, now this is not a map of Mars. This is a map that these two guys made of the moon. And I just want you to see how incredible. In fact, I'm going to load the full image so you can see how incredibly detailed. This is going to take a minute. These maps were. Okay, so they would stare at the moon for hours and hours and hours with their telescopes and make these detailed drawings of the surface of the moon. And they would name all these different craters, okay, and produce these maps. In fact, I see a crater right here that's named Schiaparelli. What were they thinking? He had these bonkers ideas. All right, well, you see this incredibly detailed map. Okay, now with this same technology and same technique, all right, look at the map that they were able to make of Mars. Okay, check this out. This is like their best map. Okay, it has these just kind of blah features. It looks like a kid drew this, right? It points to how difficult it is to observe Mars. It's small. And so with a ground-based telescope, it's no wonder that you don't know what's going on unless you have an enormous telescope. And even if you have an enormous telescope, it's still not easy. So in fact, I can show you. This is the best picture that I was ever able to take of Mars as a student, right? This is where I went to school, and I had a chance to observe Mars and take pictures of it. And so this was a telescope probably this big around, like a huge mirror, undoubtedly better than what these guys had back in the day. And this was the best picture I could take, taking hundreds of pictures, putting them all together. And you can see basically just those blah features. You can see a polar cap, some blah features. You can see a faint hint of blue that maybe there's some kind of atmospheric thing going on here. But that's about it. That's about all you can see. So it's no wonder that someone like Schiaparelli and Lowell, they were maybe letting their imaginations get a little ahead of them, and it was right on the boundary of what they could even reasonably see, right? And so that's one of the dangers of the limit, well, what would you say, letting your imagination get ahead of you. So really we were limited by these ground-based telescopes, until we had flybys. So this is like late 1960s, 70s, early 70s, when we had the very first spacecraft. It's called Mariner, and I'll get into this more later, so I don't want to get too far ahead of myself. Do flybys of the surface of Mercury, and it was just revealed to be this cratered wasteland, essentially, right? And this pretty much negated these ideas of vegetation growing over huge swaths of the planet. But of course, our vision of Mars got even more profound when we actually landed a spacecraft on it, which was done again in the 70s, which is hard to imagine. The Viking lander, you can see photos actually taken from those landers, which are absolutely astounding. But what we see, you can see frost, which is kind of cool. That was captured. But what we see is, again, a desert wasteland. Today, we have the luxury of incredible images from telescopes, not only on the Earth, but from space. And in fact, our best pictures from the Earth of Mars still would come from a spacecraft like the Hubble Space Telescope orbiting around the Earth, right? Because our ground-based telescopes can't make observations that quite match that. But even with the Hubble, what I want you to notice that even with the Hubble Space Telescope, you still see that it's a little fuzzy, right? I mean, these are our best pictures that we can get from the Earth of Mars. And I still can't see every individual crater. I still can't see the kind of detail that those two scientists, Beers and Madler, were able to capture in their Mars map. I'm sorry, in their moon map, right? That level of detail. So where does that leave us? Fortunately, we don't have to be making observations just from the Earth. We can actually send spacecraft to Mars, which we're going to take a look at shortly. And without question, the best observatory we have today around Mars is the Mars Reconnaissance Orbiter, which takes unimaginable pictures. I mean, just like absolutely incredible photographs. It's essentially like a spy satellite spying on Mars. And I mean, I gotta show you. I'll show you more, but I have to just show you like this. This is a picture of Mars of a landslide as it happens. Okay, so you've got like snowy, icy dirt falling down this really steep hill, like it's going that way, and a cloud of dust is being kicked up on Mars, and we're capturing a photo of that. Talk about detail. But again, this is only possible when you have something like a spacecraft orbiting that planet. Okay, keep in mind, this is the best we can do from the Earth. So these guys who've made these observations perhaps said some bonkers things over the time. We have to cut them some slack because they were limited by the technology that they could use at their time. Okay, Cool. So good stuff. We've kind of got the historical perspective. So now we can dive into, in our next videos, what we are currently capable of with Mars exploration.